Hey everyone, welcome back. So in this video we shall look at an example of a time series model and we shall investigate its redundancy, causality as well as invertibility. So this is the ARMA model that we shall consider, and it can be rewritten in this fashion using the backshift operator. So this appears to be an ARMA 2-2 process at this point. However, to see if it is an actual ARMA 2-2 model, we need to look at the polynomials, the autoregressive and moving average polynomials, and see if they have any common factors. So this is the autoregressive polynomial, comes from this side. So 1 minus 0.4z minus 0.45z squared. It has these two factors. The moving average polynomial comes from this side, and 1 plus z plus 0.25z squared. This is the moving average polynomial. It has this factor. So it has common factors, and we cancel them out. Then we are left with these two polynomials. And the process corresponding to this will be an ARMA 1-1 model, right? So this is order 1 and this is also order 1. And this ARMA model will look like this, right? So the autoregressive operator times xt is equal to the moving average operator on yt. So basically, if you simplify this, the process looks like this. So this is a representation, or this is a more simpler representation of the process. This is an ARMA 1-1 model. Next, we look at causality. So for causality, we look at the autoregressive polynomial. So the root of the autoregressive polynomial, and it happens to be 10.9, which is greater than 1, so outside the unit circle. Hence, the process is causal. And to write it, to see what its linear representation looks like, we use property 3.1, which is basically this. So psi operator is what we need to determine, right? Phi and theta we already know, and we will use these two to determine what psi looks like. So this is a form for psi, and determining this operator psi is the same as determining all of these constants, right? So we want to determine psi 1, psi 2, so on, so that this equation holds true. So we'll open up the terms on the left hand side, and we'll collect all of the terms with z squared, z raised to j, and so on together. And so now you can see that there is 1 on the right hand side and left hand side, so that holds true. For z, the coefficient is 0.5, and here is psi 1 minus 0.9. So we want psi 1 basically such that psi 1 minus 0.9 is equal to 0.5. Right? So this basically means psi 1 is 1.4. And then if you notice that there is no higher order z term here, right? So all of these, right, psi 2 minus 0.9, psi 1, and so on, all of these are going to be 0. So basically psi j minus 0.9, psi j minus 1 is equal to 0, which means this for j greater than 1. So let's plug in psi 2, that's j is equal to 2, we get this term. We plug in psi j is equal to 3, we get this term. And you can see that there is an immersion formula. So in general, psi j can be written as 1.4 times 0.9 raised to j minus 1 for all j greater than equal to 1. So this also holds true for j is equal to 1, right? J is equal to 1, this is 0, so it's 1.4, and we know this is 1.4. So we have all the psi terms. So with this, we know that we can rewrite xt in this particular fashion. So this is another representation of the ARMA 1-1 process, or of this particular ARMA 1-1 model. Next, we look at invertibility. So we look at the moving average polynomial. Its root is -2 outside unit circle, and therefore it's invertible. So let's look at the invertible representation. So basically, we need to determine the operator pi, and we'll use this relation to do that. So again, we need to determine constants pi 1, pi 2, and so on. We open up the terms on the left hand side. group together all the z terms, z squared, z cubed terms, and so on. And the equation must hold true, so therefore we equate the coefficients on both the sides. So basically it means pi 1 plus 0.pi is minus 0.9, so you get pi 1 is minus 1.4. Pi 2, so this has to be 0 because there's no z squared term here. So pi 2 is minus 0.5 times pi 1, but we know what pi 1 is. You plug in and get this. Pi 3 is minus half point times pi 2. We know what pi 2 is. Plug in, we get this term. Pi 4 and so on. So you can see that for pi 4 I have half raised to 3, pi 3 I have half raised to 2, pi 2 I have half raised to 1. So you can see a pattern emergent. 1.4 occurs everywhere, and also you can see that the signs are switching. Pi 1 is negative, pi 2 is positive, pi 3 is negative, pi 4 is positive, and so on. So in general we can say that pi j is minus 1 raised to j, half raised to j minus 1 times 1.4. So basically this gives us this is the invertible representation. Now we know what pi j's look like. We can plug in this expression for pi j, rearrange terms a bit, and we get this particular expression. So this xt now has another representation here, right, which is here. So so that's all for this video. In the next one we shall take a look at difference equations. See ya.